Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Din Hakim bin Muhammad Rizal Shahril. I'm from Faculty Electrical Engineering Electronics. For today, I want to express my gratitude to Madam Rohayati for giving me and my friends the opportunity to conduct ourselves in this mini project and experience with a lot of new things. So, we're going to talk about the differentiation, and me and my friends have prepared a nice explanation for you guys to understand. So, without further ado, let's begin. So, the rate of change of function is defined as dy over dx, or we can know it as fs, or we can know it as one more as y. So, in application of differentiation, we're going to learn 5 themes. And for the firstly, we're going to learn about related rates, maximum and minimum, roller theorems, mean value theorems, and determining increasing and decreasing functions. But for our mini project, we're going to explain only 2 subtopics, and it's going to be related rates and maximum and minimum.
For the first topic, related rates. In the differential calculus, related rates problem involve 2 or more variables that change at the same time, possibly at different rates. The rate of change is usually with respect to time. For objective of related rates, first, in a related rates problem, the idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity, which may be more easily measured. Second, the procedure is to find an equation that relates the 2 quantities and then use the change rule method and implicit method.
A spherical balloon is inflated at the rate of 8 cm³ per second. Find the rate of change of the surface area when the radius is 4 cm. For this solution, we will use the chain rule method to solve this problem. Okay, let's begin our first step to solve this problem. At first, we need to know and write the formula volume of sphere, also the formula area of sphere. Second step is we need to identify 2 things, which is the given information and the unknown information. For the given information, the question mentions the spherical balloon is inflated at the rate of 8 cm³ per second. That means we will write it dv over dt equals to 8. The meaning of dv over dt is the first derivative of volume with respect to time. That means it shows how volume changes with time. Let's move to the unknown information. Find the rate of change of the surface area when the radius is 4 cm. So we will write it as dA over dt equals to unknown. So we just put question mark and when the radius equals to 4 cm. After we have successfully identified the formula to use for the sphere, we need to differentiate the formula. Then we need to rewrite the equation first, which is dA over dt equals to dA over dr multiply dr over dv multiply dv over dt. Fifth step, we need to substitute the value of the rate into the equation. So we assign dA over dr equals to 8 pi r, dr over dv equals to 1 over 4 pi r square, and dv over dt equals to 8. The 1 over 4 pi r square is actually dv over dr value. We just flip it to become dr over dv, so the rate of change with respect to r rather than v. This is called taking the reciprocal of the derivative. So we get the answer is 16 over dr. The last step is to get the final answer, which is assign the value of radius equals to 4. Then 16 is divided by 4. So the final answer is 4 cm² per second. In conclusion, thus, if we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing. Now, let's go to topic 2, which is maximum and minimum. The process of finding maximum or minimum are called optimization to solve real-world optimization challenges. These problems focus on finding the best maximum or worst minimum value of a quantity, such as cost, profit, area, volume, or time, under given constraints. Determining the increase or decreasing of a function, it is also can be used for speed or distance. Determining the increase or decreasing of a function, it also can be used for speed or distance. In real life, we usually use maximum and minimum to maximize the profit in a company or minimize the cost to to make a particular object. However, in calculus, we use maximum and minimum to calculate the highest and lowest point of the curve in a graph or to know its turning point. When to apply maximum and minimum? We apply maximum and minimum to determining the increase or decreasing of a function. Furthermore, it also can be used for speed or distance. Did you know our topic, it was used to find the maximum and the minimum values of a particular function.
Now, for the problem statement, the diagram shows a rectangular tank with no top made from stainless steel. The volume of the box is 250 cm3. The base A square with side at cm. The material for the bottom will cost RM2 per cm square, and the material for the side will cost RM4 per cm square. Now, from the problem, let's bring out all the information that we have. So firstly, we have the tank has no top and the base is a square with side length at cm. So second, the height of the tank is 4 cm. And the third, the volume of the tank is 250 cm3. So the volume is going to be h square y equals to 250, and y is equals to 250 over h square. So and the cost for bottom material is going to be RM2 per cm square, and while for the side material is going to cost RM4 per cm square. Okay, now for the question that was given, it's gonna be like C equals to 2x squared plus 4000 over x. We need to prove this equation. So firstly, we need to know the volume for the cube is gonna be A or A cube. A is gonna be h, and for the volume of this cube is gonna be V equals to 250 centimeter cube. So firstly, we need to make it into a continuous equation. So V equals to 250 equals to A cube equals to x squared y. Now rearrange back the equation that use the other pen. We can use the black pen right now. Okay, wait a moment. So x squared y equals to 215, and we're gonna rearrange back. Put y equals to 250 over x squared. So remember, after we finish this, ignore first. Okay, so we know the value for the bottom and the side. For bottom, it's gonna be RM2, and for the side, it's gonna be RM4. But remember guys, this price is for per centimeter square. Don't forget about it. Now, let's find the cost. No, my bad. The price for bottom. So it's gonna be, the equation is gonna be cost of bottom equals to 2x squared. So now I'm gonna use the pen, red pen, to mark number 2. Why we use 2? Because 2 is equals to RM2, or we can say it is for the price. And for the x square, I'm using the blue pen to highlight it as the area. Therefore, we know that the cost of bottom is 2x squared. Then let's proceed to the cost of sides. So the equation for the cost of side is going to be cost of side equals to 4xy. Now we need to remember this. I'm using the red pen because I want to highlight to you guys that y is not, we can substitute it with the equation that we have created. Therefore, the answer is not going to be 4xy, it's going to be 4x multiplied by 250 over x squared. And the final equation that we get for the cost of sides is going to be 1000 over x. Now let me write this first for you guys to understand. For the final step, we can compile everything that we have to find the cost of the cube. So it's going to be C equals to 2x squared. 2x squared is for the bottom, and plus 4 multiplied by 1000 over x. 4, we are using the 4 because the 4 is for the side of the cube. Now the simplify I'm using with the blue pen is going to be 2x squared plus 4000 over x. Let me put some note for you guys to make sure you guys understand what I'm writing about. Then therefore, C is equal to 2x squared plus 4000 over x. and the equation is proven. Well done, guys.
For equation B, we use same information with equation A. So, we have to find the minimum cost for constructing the tank. First step, we have to differentiate the C. The equation is dc over dx equal to 4x minus 4000 over x squared. Second step, we have to set dc over x equal to 0. So the equation should be 4x equal to 4000 x squared. Fourth step, we have to solve x. So the equation is 4 cubed equal to 4000. After we solve it, and we get x equal to 10. So next step, we need to verify minimum using the second derivative. So the equation is d square c over dx square equal to 4 plus 8000 over x cubed. After we differentiate the equation, we substitute x equal to 10 to the equation. So we get the d square c over dx square equal to 4.8. Step, we have to find y from the volume equation. The equation is x square y equal to 250. And we have to substitute x equal to 10 to the equation. After we solve it, we get y equal to 2.5. So the last step, we calculate the minimum cost. We have substitute x equal to 10 in equation C. After we solve it, we get the minimum cost is Rm600.
Lastly, conclusion for maximum and minimum. Therefore, identifying the right formula and accomplishing both first and second derivatives correctly will lead to a solid answer, a maximum or a minimum cost.
Thank you guys for everything.
Bye.